Lesson 6, Graphing Sinusoidal Functions. So when we're graphing, we do have an equation, and this is the equation that we use. And every part has its own purpose. So our A is our amplitude, our B affects our period length, C is a horizontal translation, so we move it left and right, and D moves it up and down, and also helps us find our midline. So for the graph y equals 2 sine 4x plus 1 from 0 to 360 degrees, we want to describe all the transformations, and then we're going to graph it. So for our A value is our amplitude. So our amplitude is 2. Our B value is our period length. And the way that we do it, because we're doing with degrees, we go 360 divided by our B value, which is 4. So 360 divided by 4 is 90 degrees. That is our period length. Our C value is our horizontal translation, and because there's nothing in brackets, there is no horizontal translation. And our D value is our vertical translation, which is 1. So we know our midline is 1. Our max point therefore would be 1 plus the amplitude, which is 2, so it's a 3. And our minimum point will be 1 minus the amplitude, which is negative 1. Our range would be y such that negative 1 is less than or equal to y, which is less than or equal to 3 for all the elements of the real number. And we know that from our min and our max that we just found. We also know that because it has not moved from left to right, our y-intercept is 1. And we also remember that this is a sine function. And two other things that are really important to help us graph is we take our period length and we divide it in half, which would be 45 degrees. That will give us the middle where it will intercept the midline. And if we take 90 and divide it by 4, it's 22.5. And that will help us find our minimum and maximum points. So the first thing that we're going to do is we're going to graph our midline. And we're going to go every 2 is going to be worth 1. So our midline is right here. You can draw it in lightly just so that we remember where the middle of our graph is. Now we're going to draw in our units. So because we're working with 90 degrees, it's a good number to go up by is going to be 30. And we want to spread it out a little bit so that we have room, but we also want to fit 360 degrees on our graph. So we're going to try 30. So this is 30, this would be 60, 90, 120, 150, 210, 240, 270, 300, 330, 360. So that fits on our graph pretty good. Now we're going to plot our min and our max points as well as the end of our period. So we know that it hasn't moved left and right, and our y-intercept is at 0. So we start there. Our period is 90, so our end point is here. That means that we are going to cross the midline again at 45 degrees, which is halfway. And now our minimum and our maximum will be at 22.5, which is halfway between this line. And they're at 3 and negative 1. So there's our first bump of our sine function. So it's going to look like this. And now we want to draw it from 0 to 360 degrees, so we have to keep going. So we'll just keep drawing all of our lines. So we have a maximum, then we hit the midline, then we have a minimum, then we hit the midline, and that should be another 90 degrees. And it is, I just missed 180. So our second one ends at 180, our third one will end at 270, and our last one should end at 360. And there's points in the middle of each, and then we have a maximum, then a minimum, then a maximum, then a minimum. So our sine function will look like this. So that is that graph. Alright, example 2, same thing. So our A is our amplitude, which is 3. Our period length is from B, so we're dealing with degrees, so we're going to take 360 degrees divided by our B value, which is 2, which is 180 degrees. So our period length is 180. Our C is a horizontal translation of 45 degrees. So that means it is moving 45 degrees to the right. It's always the opposite direction of the sine. And D is our vertical translation, and there is none. So we're going to also figure out what our midline is. So because it hasn't moved up and down at all, our midline is 0. So our maximum point is 0 plus 3, which is 3. And our minimum point is 0 minus 3, which is negative 3. Our range is y such that negative 3 is less than or equal to y, less than or equal to 3 for all the elements of the real numbers. And then another useful piece of information is that 180 divided by 2 is 90, and 180 divided by 4 is 45. So those are going to be useful information for us. So first we're going to draw our midline in. It's at 0, so we don't actually have to draw that in. Now we want to label our axes. So because we're moving 45 to the right, we're going to use 45. So we're going to go up every 2 is 45. So 45, 90. 135, 180. 225, 270, 315, and 360. And up and down, we can go every 2 is 1. 1, 2, 3. Negative 1, negative 2, negative 3. Alright, this one is a little bit different because we have a horizontal translation. So because of that, our starting point is at 45 degrees. So if our period length is starting at 45 degrees, to go a full period would be 45 plus 180, which would be 225. So that means it's going to end at 225. Our halfway point is going to be 45 degrees plus 90, which is 135. So it's going to hit the midline here. And that means that our max is going to be at 90 degrees, halfway between, and our min is at 180 degrees for the first period. So we're going to graph those points. So our maximum is at 3, our minimum is at negative 3. And I put that in the wrong spot. So our one cycle would look like this. And we have to keep going, so we're going to go to our maximum, midline, and then to our minimum to get to 360. But we also have to get to from 0. It has to be between 0 and 360. So if you were to move 2 to the left from the beginning of our function, it would go down to a minimum. So we kind of get the end of the previous function. So that is how you would graph that. All right, for our last example, we have a cosine. So our A is still our amplitude, which is 2. Our period length is B, so we're going to take 360 and divide it by half. So because this one is a fraction, it's actually going to double to 720. We have a horizontal translation of 60 degrees to the right, because remember, horizontal is always the opposite sign. And we have a vertical translation of -1. So our midline is at -1. Our amplitude, or our maximum then, we use our amplitude, so we go -1 plus 2, which is 1, and our minimum is -1 minus 2, which is -3. So our range is y such that -1 is less than or equal to y, which is less than or equal to -3 for all the elements of the real number set. And now we are going to graph. So some important information. Our period length is 720. That means that half of it is 360. And a quarter of it is 180. Now, because we're starting at 60, that's going to also affect things as well. So first let's put in our units. So up and down we can go 1, 2, 3, -1, -2, -3. And every 2 we're going to go up by 90. So we got 360, 450, 540, 630, 720, and 810. That's probably good enough. Alright, so first thing we have to get over with is the 60 degrees to the right. So that means we're going to start at 60 degrees. So the middle of our section is going to be 360 plus 60 degrees. And we want to find our maximums as well. So we're going to go up in groups of 180. So if we go 360 plus 180, we get 240. And because when it's a cosine, we start high and we go down to the minimum. Oh my goodness. And we go back up. That means that when we plot our 60 degrees first, this is going to be a max. So this one has to be touching the midline. And then when we take 240 and add another 180, this is going to be our minimum. And then when we take, I guess I should give you that number, 240 plus 180 is equal to 420. And that will be our minimum. And then when we take 420 and add 180, we get 600, and this is going to be our midline again. And our last one would be 600 plus 180, which is 780, and that would be our maximum again. So we're going to plot this, and our first point is at 60 and 90 degrees. So the most important thing is that when you plot your 60 degrees, it's the same consistently, because it's not exactly on a spot. It's going to be somewhere between 45 and 90. So our maximum is 1. So I'm going to plot this here at 60 degrees. Then our midline, which we can graph in at 1. I'll do it in green actually. We're going to touch the midline at 240 degrees. So 240 degrees is going to be just past this line here. So as you can see, to get from this point here, we go 1, 2, 3, 4, 5 spaces. So to get to the next one, we're going to go 1, 2, 3, 4, 5. But this one is going to be a minimum at -3. And if you look, this matches our next number, which was 420. Except it didn't, because we're actually only going 4. I don't know what I'm doing. 1, 2, 3, 4. 1, 2, 3, 4. It should be right here. So there's our next point. Then we're going to go 1, 2, 3, 4. This is going to touch the midline right here. Then we're going to go 1, 2, 3, 4. And this is going to touch our maximum. And that, again, these all match our numbers. 780 is our last point. 600 is our midline. 420 is our minimum. So when we graph this, we have our cosine function that looks like this. If we were to keep going to the left, we would do the same thing. It'd be 1, 2, 3, 4, except it touches our midline. So you could keep going to the left as well. 1, 2, 3, 4 would be somewhere over here. We could keep going to the right as well. 1, 2, 3, 4. It'll touch the midline there. So there is our graphed function.